Okay, now this topic is one of the most important topic from the whole unit of calculus. Okay, so all the questions are of word problem, in this case optimization problem, and here mainly we are optimizing means either you are maximizing or minimizing. Okay, so we are optimizing the mensuration quantities, okay, like volume, area, surface area, all this. Okay, so here we are having optimization problems mainly on the mensuration quantities, so that is one thing you have to remember. And in the board exam, okay, so if I tell you in context with the exam oriented, so then one question will definitely come from this topic, which will be of 6 marks. So this topic is very important, so always there will be one question from this topic in the board exam which will be of 6 marks, and this is not so difficult. Okay, so you should for this type of question you should have a very good understanding of the question first of all, and then you need the you need all the formulas of the mensuration. Okay, and obviously derivative, you know. Okay, so because it is one field where we are applying derivative. Okay, so derivative, the basic concepts of derivative, how you are differentiating a function. Okay, and then you need the you need all the formulas of mensuration. Okay, so these are the things we need in this type of question. Okay, so I will take one example and then we'll explain how these questions are to be solved. Okay, now first we will take one simple example before going to a typical question of the optimization problem of mensuration quantities. Okay, so first we will take one simple example and then you will try to understand how these questions are to be solved. All the patterns we are going to follow here is same. Okay, now let's read this question carefully. Find two positive numbers x and y, okay, such that x plus y is equals to 24 and whose product is as large as possible, or you can say whose product is maximum. Okay, okay, now the sum of the two numbers are given here. The sum is given. Okay, so you are given that x and the sum of x and y is 24, so sum is given and the product is to be maximized. Now when I say optimization problem, okay, so then one quantity, it is to be either maximize or minimize. Okay, so here we have to find the not find, okay, we have to maximize it. It is given that the product is maximum, so you have to find the values of x and y such that its sum is 24 and the product is maximum, right? Now when I say that sum of two number is 24, then you will get so many such pairs. You can take 12 and 12, right? 12 plus 12 is 24. Also you can take 10 and 14, right? So 10 plus like this. If you take 12, 12, this is one pair, the sum is 24. Then also you can take, this is one pair. Okay, also you can take 21, 3, right? You can take 22, 2, right? So all these are pairs whose sum is 24, right? But you are asked to find out that particular pair for which the product is maximum, right? Which means we are maximizing the product. Okay, so I just wanted to say that in this type of question, optimization problem, whether it is just arithmetic problems or mensuration problems on optimization, always you will be given one quantity. Here the sum is given and one quantity is to be optimized, either it is to be maximized or minimized. Okay, so here the quantity sum is given, right, and product is to be maximized, okay, or minimized. Now here in this question it is to be maximized. So all the questions will be always of this type. One quantity will be given and one quantity is to be optimized, either it is to be maximized or to minimize. Okay, so the same thing happens even for the optimization problems on mensuration quantities. Okay, so you remember this, in all this type of question of optimization problem, what you will have is one of the quantity will be given and one of the quantity is to be maximized. So you should be able to differentiate these two. which is the given quantity and which quantity is to be optimized. So you should be able to differentiate between these two first of all. Okay, so okay, now what we have is so first actually we need to first of all we need to define the variables which we are going to use in the solution. But since here in this question the variables are already given, okay, so now you are given one of the, what is given, we are x plus y is equals to 24. This is given. Okay, what is to be maximized? Maximize, you have to maximize the product. Product means x into y, is it? Okay, now you look here, whatever given is, okay, always the quantity will contain two variables. So therefore where this given is to be used is to convert one variable in terms of the other. Okay, so therefore from this you can have, from this given x plus y is equals to 24, you can write y is equals to 24 minus x, or you can write x is equals to 24 minus y. It's same. Okay, but the objective behind this is you are trying to express one variable in terms of the other variable. So you will write this y is equals to 24 minus x. So this is how you will do it, right? So always whatever given is there in the question, given quantity, it is to be used to convert one variable in terms of the other variable. Okay, now whatever the quantity is to be maximized or to minimize, optimize, whatever the quantity is to be optimized, so again it is in terms of two variables, right? Now the quantity which is to be optimized is to be differentiated, right? So when I say that a quantity is to be differentiated, then you know that when you use this notation, right, that if I write, suppose say if I write d by dx, then it means whatever quantity you write here, that is to be differentiated with respect to x. Okay, so when you are differentiating some quantity, then it can be done only with one variable. You cannot write derivative of this term with respect to xy. You cannot do that, right? So when you are finding out the derivative of a quantity, that quantity can be differentiated with respect to only one variable. Remember that, okay? But since here the product, it is consisting of two variables, so therefore using this you will try to express this quantity which is to be optimized in terms of one variable. So if I write, what is this? This is the product. P is equals to xy. Now this quantity is to be optimized. Okay, so first you will either try to express this in terms of x, or you will try to express this in terms of y, but it has to be converted in terms of only one variable. Okay, so I will write P is equals to x. Now instead of y I can write 24 minus x. I can do that, right? Now my P is in terms of 24 minus x, 24x. Okay, I have this 24x minus x square. Now my P is in terms of one variable. Earlier it was in terms of two variables, right? So therefore using the given quantity, okay, I'm able to express my product in terms of one variable. Now I can differentiate this with respect to x. Okay, if some of you have this this express P in terms of y, then you will differentiate P with respect to y. So according to which variable you had expressed, according to that you have to differentiate. Okay, now you will differentiate this. You will find out dp by dx. You will find out the derivative of P with respect to x. So that is 24. So that is 24 minus 2x, right? So we get here, this is dp by dx is equals to, now from this if I take out 2 common, so I have 12 minus x. Okay, so now I will, okay, now you please follow the steps always. Okay, so first you will differentiate the quantity which is to be optimized. Okay, and you will try to simplify it till the end, and after that you will find the critical point. Okay, then I will explain why we are finding the critical point. So now we have for critical point, what do we have? We have okay, dp by dx is equals to 0. Okay, So therefore I have what is that, 2 into 12 minus x is equals to 0, right? So 2 is a non-zero term, so therefore when I say that product of these two is equals to 0, then either one of them has to be 0, then only this equation is valid, right? So therefore 2 cannot be 0, so therefore this term has to be 0, so therefore from this I have x is equals to 12. When x is equals to 12, this term will be 0, so therefore 2 into 0 is 0. So that is the only possibility we have, okay? So now we get this x is equals to 12, okay? Now what is this x? It is one of the number, okay? Now when I say that x equals to 12 is the critical point, then by that I mean the product is, okay, either attaining the product is either maximum when one of the number x is 12, or the product is minimum when one of the number x is 12, right? So when you get critical point critical point means the function is changing its behavior, which means either it will be somewhat like this. If it happens, then this is the minimum value, or it can be like this. If this happens, then it is the maximum value, okay? So now these are the two possibilities. Now we have to find out that, okay? So now when one of the, now from this you should be this much clear enough, that is when one of the number, okay, out of x and y, when one of the number is 12, we are not talking about the other number, we are just talking about one number, okay? So we are saying that when x is equals to 12, when one of the number is 12, then the product is either maximum or minimum, okay? But since the question is maximizing problem, then obviously at this when x is equals to 12, the product is maximum. So when x is 12, what will be the other number? That you can find out. But we have to prove that it is maximum when one of the number is 12, okay? So for that we are going to use second derivative test, okay? So these are the steps you have to follow. Up to this, I think it is clear, right? We got this. Then you will find out d2p by dx square. That is the second derivative, okay, of this. So that will be, this is equals to, okay, this is equals to, now 2, this is coefficient of this term, so, or you can just differentiate here, dp by dx is equals to 24 minus 2x. So that is to be differentiated again. So derivative of 24 is 0. So derivative of minus 2x is negative 2, right? So now you recall second derivative test, okay? So second derivative test in local maxima and minima, we had discussed that if the second order derivative is negative, then it means the function is attaining its local maximum value at that point. So it means it is maximum value. So already we got here d2p by dx squared is equals to negative 2, which is less than 0, right? So when you put x is equals to 12 over here, so this is already a constant, so you cannot put it over here. Actually, if you get some value here, then this is the most important step. So you have to show that when you put this value here, okay, that is a negative term, you have to show that if the question is maximizing problem, okay? So since, but here in this question it's quite simple, we already get a constant here, so whatever value you put, that will be same. So negative 2 means it is less than 0, so you don't have to substitute anything over here. So directly you will write, therefore, okay, therefore you will write product is maximum. So which means second order derivative, when it is negative, then it is maximum. So therefore product is maximum when x is equals to 12. Okay, so then what you have, so we have product is maximum when x is equals to 12, right? So therefore when x is equals to 12, what do you have? Okay, so you can do this. When x is equals to 12, y is also equals to 12, sum has to be 24. So when x is equals to 12, 24 minus 12 is 12. So when x is equals to 12, y is equals to 12, or you can use this implies sign. So therefore product is maximum when x is equals to 12 and y is equals to 12. Is that clear? So this is how it is to be done. Okay, so now I will repeat here one thing. Okay, in all the type of optimization problems, okay, there will be two quantities in the question. Always for all types of question in optimization problem, you will always see two quantities in the question, where one of the quantity is given, it's constant, where one of the quantity is given, and the other quantity is to be optimized. Optimized means either it is to be maximized or to be minimized. Here in this question it is a maximization problem. Okay, then whatever given quantity you have, that is to be used for expressing one variable in terms of the other variable. Now this method is applicable for all types of optimization problem. Okay, so you will given quantity, you will express one variable in terms of the other, and the quantity which is to be optimized, that is to be differentiated, and that is to be converted in terms of only one variable. Okay, because in terms of two variable we cannot differentiate that, so therefore you will express the given this quantity which is to be optimized in terms of one variable. Okay, now this is in terms of only x, variable x. Then you will differentiate it, right, simplify it, and you will get the critical point, which means at that critical point, whatever quantity you had differentiated, that quantity is attaining either maximum value or minimum value. Okay, so then if the question is maximization problem, then by second derivative test you have to show that second derivative test is negative at that point if it is a maximization problem. And if it is a minimization problem, then you will find second order derivative and simplify it, substituting x is equals to the critical point, and you will get a positive value for second order derivative test, which means that critical point is the minimum value of the function. So this is how this optimization problem is to be done, right? Okay, so we will take one more example, and I hope you will be much clearer after that. Now we shall look at the second example, and I've taken it from the mensuration concept. Okay, show that of all the rectangles inscribed in a given fixed circle. Now when I say that given fixed circle means a circle whose radius is given. Okay, show that of all the rectangles inscribed in a given fixed circle, the square has maximum area. Okay, so now we are going to find out that. So I think by the question you must be clear that area is to be maximized, right? So first let me explain this question using a rough figure. There is a circle whose fixed circle, so which means radius is fixed, it's constant, radius is fixed. Now in this circle you can inscribe, means you can draw a rectangle in the circle touching all its vertices. You will for a rectangle there will be 4 vertices, so all the 4 vertices has to be on the circle. If I write a rectangle like this, it is not inscribed in the rectangle, the concept is not that. Okay, so inscribed means you have to draw a rectangle in this circle where all the vertices of the rectangle has to be on the circle. Okay, so this is one of the rectangle you can have. Now you can see that this rectangle, okay, is inscribed in the circle. Similarly, I can inscribe the rectangle like this. Okay, this is also one rectangle which is inscribed in this circle, right? Also I can inscribe the rectangle somewhat like this. So this is also one rectangle which is inscribed in the circle, right? So if you keep on drawing like this, then you will get infinitely many rectangles which can be inscribed in the circle. So this it is there. Now it is said that you have to show that of all these rectangles, now this is one rectangle, this is one rectangle, this is one rectangle, right? So you have to show that out of all these rectangles, okay, one of the rectangle will be square. Square is a special type of rectangle where length and breadth are same. Okay, so out of all these rectangles, the rectangle which is a square will have the maximum area, so that is to be shown. Okay, so now this I will do it by, it's quite simple. Okay, so okay, we will do it like this. Okay, let me have a circle. Okay, and I will take a rectangle inside it. First I need not write a circle, square. I will prove it. Okay, so we are given that it's a fixed circle, so this is the radius of this circle, and I will join this, so I will get 2 radii of the circle. So therefore this whole length I can write it as 2r. Is that clear? And let x and y be the length and breadth of the rectangle. Okay. Now we are given the first okay, we have two variables x and y. So in the previous question directly you were given the relationship between x and y. The sum is given as 24. So x plus y is equals to 24. That relationship was given. Okay, but here we are not given any relationship. So therefore we have to establish it by using the radius that is given quantity here. So if this is x, right? So you can have a link or relation between x and y in this right triangle. Since it's a rectangle, the angle is 90 degree. Okay, so now in a right triangle, by Pythagoras theorem, what do we have? X square plus y square is equals to okay, perpendicular square plus base square is equals to hypotenuse square. So that is 2r whole square. So I have y square is equals to 4r square minus x square. So y is equals to square root of 4r square minus x square, right? So now you can see the given radius, I had used it to express y in terms of x or x in terms of y, you can do. Okay, so the given quantity, like in the previous example, I had used the sum x plus y is equals to 24 in expressing y in terms of x. Similarly, I'm doing it here. I'd express y in terms of x. Also, you can write x in terms of y. It's same, okay? But you have to express one variable in terms of the other. Now here, which quantity is to be maximized? Area is to be maximized. You have to find maximum area, which means area is to be maximized. Now you know that when area is to be maximized, then it means you have to differentiate area, okay? So now what is the area of the rectangle? It is x into y, okay? So you have to find out, or you have to prove that out of all the rectangles, okay, square has the maximum area, okay? So which means you have to show that x is equals to y when it has the maximum area, okay? So when you express a in terms of two variables, you cannot differentiate it. So therefore you have to express in one variable. So taking this, so I got x is a is equals to x into, instead of y, I will write this square root of 4r square minus x square. Now one thing, x is the variable, r is not variable, r is constant. It is the radius of the circle which is given, okay? R is constant and x is the variable. So therefore now I had expressed area in terms of variable x, okay? Now you look here, you can differentiate it directly. If so, if you are doing that, then that will be very lengthy, because you have to apply product rule, and then you have to apply this chain rule over here, okay? So that will be quite lengthy. So what you can, okay, or you can do, I will try to eliminate the square root. So therefore I will write a square is equals to x square into, okay, this is like this, I'm taking a whole square root, so a square, and this square is to be applied on both, so x square and this square root cancels, so you have 4r square minus x square, okay? Now I will differentiate a square. It's same to differentiate a and a square, because when area is increasing, area square will also increase. If area is decreasing, area square will also decrease. So it's same, okay? So therefore now I will differentiate this quantity with respect to x, okay? Or first you can simplify this. A square is equals to 4r square x square minus x raised to 4. Now you can differentiate this. This is just a quantity, okay? Don't get confused. A square is just a quantity, okay? With respect to x, okay? So this is 4r square, as it is derivative of x square is 2x, so therefore it is 8r square x minus 4x raised to 3, okay? So from this 2 you can take out 4x common, okay? 2r square minus, here I have x square, right? So you can write it like this. So therefore then you will find the critical points, okay? Okay, for critical points you will write this is equals to 0, so which means 4x into 2r square minus x square is equals to 0. Okay, now either this has to be 0, 4 is non-zero term, or this has to be 0. So you get x is equals to 0, or this 2r square minus x squared is equals to 0. So which means this implies x squared is equals to 2r squared. So x is equals to square root of 2r. Okay, so we get this value. Either x is equals to 0 or x is equals to square root of 2r. Okay, but x is the length of the rectangle, which cannot be 0. X cannot be 0. Okay, so this is the only possibility we have, which means when x is equals to square root of 2 into r, the area is either maximum or minimum. Now we have to show that it is maximum. So therefore now you will use second derivative. Okay, so this a square is to be differentiated twice, so that is, you will write it like this. A squared is just a quantity. Okay, so a square, or second order derivative of a square, so this is equals to, now you have to differentiate, where is it, this one. Okay, so you have to differentiate this. So here this will be no, sorry. Okay, you have to differentiate this one, right? Okay, you have to differentiate this one, right? So this will be 8r square. 8r square, derivative of x is 1, and this is 4 3 is a 12x square. 12x square. Okay, so now you have to substitute the value of x here. So that will be d square d2 square at x is equals to, now you have to put this root 2r, so that is equals to 8r square minus 12 into x square, so that is root 2r whole square. You have to simplify it till the end. Okay, till you are able to show that this second order derivative is either negative or positive. So till that you have to simplify it. So this is the most important step in this question. Okay, in the previous example we directly got that constant -2, so we don't have to further solve. But here in this case you get this x here, so you have to simplify it taking this value of x. Okay, so now this is equals to 8r square minus 12 into whole square, so that is 2r square, so that is equals to 8r square minus 24r square. Okay, now you can see from this you can take out 8r square common. Okay, so what I'm left with, this is 1. Okay, minus 8 3 is a 24. So you have this is equals to, what do you have? Okay, directly you can subtract what I'm doing here. Okay, r square, these two are like terms, so you can subtract, so that is negative 16 r square. Okay, now what is this r? R means it is the radius of the circle. Okay, fixed circle, so which is positive, even though it is r square, right? So r square, so this term is always positive. So when you multiply a positive term with a negative term, this is always negative. So this term is always less than 0. It is always negative, right? So which means when the second order derivative is less than 0 at x is equals to this, so then this is the point of local minima, local maximum, right? When it's less than 0, it's maximum. So therefore area is maximum, right? So therefore you can say that area is, or you can say therefore x equals to root 2r is the point of local maxima. So therefore when when x is equals to square root of 2r, now you have to find the value of y. Okay, so you put it here. Okay, then you solve it. Instead of x you put root 2r, and then you solve it, you will get y is equals to root 2r, which means this implies x is equals to y. Okay, so when x is equals to y, when length is equals to breadth, okay, so then what do you have? it's a square. So the area is maximum when x is equals to root 2r, which gives us x is equals to y. So hence we have the area of the rectangle inscribed in the circle is maximum when that rectangle is a square. So this is how it is to be done. So you have to conclude this. So therefore area is maximum when it is a square. Is that clear? So you can compare the first example and second example, and you will see that the pattern is absolutely same in both the examples, both the two examples. In the question you will see that one of the quantity is given and one of the quantity is to optimize. Okay, so the given quantity is to be used for expressing one variable in terms of the other variable, and with that you will differentiate the quantity which is to be optimized. Okay, and using second order derivative test you will check whether that critical point is the point of local maxima or minima. Is that clear? So this is how it is to be done. Okay, so now I'm repeating it. This question, this optimization problem is very important. Always there is one question for sure in CBSE board exam which will be of 6 marks. So this type of question is very important, and you will see in the exercise 6.5. okay, exercise 6.5, I had given you one question, that is okay, in exercise 6.5 I asked you to do question number 3. I asked you to solve question number 3 using first derivative and second derivative test. Okay, today you will do this exercise 6.5, question number 5. Okay, question number 5, and then question number 13 onwards. Okay, question number 5 is on absolute maximum and absolute minimum, and question number 13 onwards, all the questions are on optimization problem. Okay, so there are up to 26 questions, question 13 to 26 questions, right? 26th. So all these questions are on optimization problem. So you see how many questions you can do. Try to do the maximum number of questions you can. If possible, you try to solve all the questions, because this is very important topic. And if not, then see how many questions you can do. Okay, so question number 13 onwards you will do at least 5 questions, and question number 5 you will do that completely. It is on absolute maximum and absolute minimum. Okay, so this is your assignment. So now we had completed the topic of local maxima and minima, in which you have 3 main topics: absolute maximum and absolute minimum, finding the point of local maxima and minima, and optimization problem. Okay, and to clarify these concepts you will do question number 3, question number 5, and question number 13 onwards. You will do at least 5 questions. Okay, from 13 to 26. Okay, so that's it. So here I'll conclude my lesson today, and hope you had understood okay what I taught here about the optimization problem, and please try to practice as much as you can on this particular topic, optimization problem, as it is a very important topic from the whole unit of calculus. So for sure there will be one question from this topic. So therefore I think even now, if you know this much, that this one question from this topic is to come, then I think obviously you have to do a lot of practice on this. Okay, and make sure that you will be able to score 6 marks from this topic. Okay, yeah, so I will conclude here, and I'll see you in the next class. So till then, take care and stay safe. Thank you.